In this tutorial, I'm going to introduce the Winson WCS Current Sensors. I've written a library for all these series of WCS current sensors from Winson, where you can measure the currents from very low value of milliampere up to 50 ampere or higher. And the library will work with all of them. As you can see, my electronic load shows 20 ampere, and on the serial monitor, we are reading also 20 ampere. To measure the current and display it on a LCD1602 or LCD2004 with I2C module, which has only 4 wires. I'm going to show you how to implement the OverCurrent Protection for Winson WCS Current Sensor and implement it using Robojax WCS Library to disconnect the current when it reaches certain value. We're going to use a relay, and this will be implemented with the LCD and without the LCD. Winson Semiconductor from Taiwan is producing tons of Hall effect sensors, and these are the versions. As you can see, they go up to 40 ampere, 50 ampere. These are the versions that you can solder the wire directly on the sensor, and also they have through-hole versions. These are all the versions, and 200 ampere, 100 ampere, and different values, but they have different sensitivity. Sensitivities are shown in here. That they all consume 3.5 milliampere, which is very minimal and acceptable for many applications. And these are the sensitivities. Keep in mind, if you're purchasing any of these values, try to select the one that has highest sensitivity, because you will get better result. But the problem is, for example, this one has very high sensitivity at 5 ampere maximum. So the higher the value that you select, the lower the sensitivity becomes. For that reason, I've selected the 35 with 66 milliampere, and there was also 35 ampere with 70. So this Winson WCS sensors are offered in many shapes and form. They made it on PCB. They made them also as a big, larger module with even LED display with attached relay and so many other features. So the library that I have written will make it very easy to use all of them. I've seen a lot of requests and also existence of these current sensors from Winson. They're available on Amazon, AliExpress, eBay, everywhere. I decided to write a library for this. So you can use all Winson WCS. There are different series, but these are WCS series, which are the majority of them, over 15 or 20 types. So you can use them with Arduino and will be able to measure the current. So I've implemented a zero current recording. When there is no current, always all the current sensors will read some value, so we have to save that, and then later on when the current is connected, subtract it. In order to be assured that the zero current have been saved, I've implemented a LED indicator here that have been connected to pin 2 and ground via a 300 ohm resistor. So once the value is saved and recorded, this will turn on, while letting you know that it has been recorded, so you can proceed with turning on your load. So this will be used when the load is not connected, and within 5 seconds it will record it. You can change the time and make it 1 second, 2 seconds, or even more. It's very flexible. The library is very flexible. You just select your model and some very basic settings, and it will just work fine with all the WCS sensors. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout. All of them. VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. And if you have this type, VDD, ground, and analog out, or for this one as well, the same way, VDD, ground, and analog out, the pins are connected in the same way. For example, you might get a version something like this, that you have to solder your 2 wires in these 2 pins, and then these 3 pins are power supply, ground, and the Vout for the current and the version that I'm testing today is 1800, and I've chosen this because it goes up to 35 ampere and it has just 3 terminals. Very simple. Either you can use it like this, which is very linear, 66 millivolts per ampere, and the module is sold like this, or maybe just a bare module. The code that I've written will work with all of these. You might find it in a black or blue version. Pay attention when you're wiring the bare module without the PCB. You have to connect between the V out and the ground. We need to connect a capacitor, 0.01 microfarad, that is 10 nanofarad, to 0.1 microfarad, which is 100 nanofarad, to reduce the noise. But if you're getting PCB, the capacitor is already included. This is a capacitor. And on this module, this is a capacitor. It's already included. Here's the datasheet for the Winson WCS1800, the Hall effect sensor. The diameter for this hole is 9 millimeters, and you can measure AC and DC current. 0 to 35 ampere, 66 millivolts per ampere is the sensitivity. And this needs operating voltage, which can operate from 3 to 12 volts, and it needs 3 milliampere current. Isolation voltage is 4000, so it's directly related to the supply voltage, and bandwidth is 23 kilohertz. And for AC, you can measure up to AC RMS up to 25 ampere. They're in negative or positive direction at 25 degrees Celsius and 5 volts. This is the output that we are getting. When there is no current, we are getting 2.5 volts. If we are connecting it to 5 volts, that's very important. Pay attention. So this module will always output 2.5 volts, but it will fluctuate from 2.35 to 2.65. So keep that in mind. This is actually the sensitivity at 10 volts. They have measured it, so it is 66. And here is the error. You might get 56 to 66 to 76. So from 56 it goes 10 up and 10 down. DC 35 and 5 volts RMS 25 ampere. And temperature drift, when there is zero current, it will be plus minus 1 millivolts per degree Celsius. So every degree Celsius will add 1 millivolts. Keep that in mind. This is the negative of my power supply, and that's the positive. The negative I've connected directly. This is the load. I'm connecting it to my load. And this is the positive, passing it through this, and will be connected to my load. This is my load. And here I've prepared this wire. This is the 10 AWG wire that can handle over 70 ampere. So I'm going to connect it like that. And now let's see, this is your load, and you have a battery and you have a sensor. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have the sensor, this shape of sensor that will pass hole through, or maybe a module, something like this, that the 2 wire will be connected here, which I'm going to show you, or this module, or this type with the 2 terminal on the side, or if you have something like this, or something like this. You can put it between the negative and the load, or you can put it between the positive and the load, or you can put this one between positive and the load, and it will just pass through that. Or you can put it at the negative, the same module here. Or if you have this type of module, you can solder the 2 wires between the negative and the load, or between the positive and the load. And if you have this PCB version, you can connect the 2 wires in this 2 terminal, or between the negative and the load. And if you have this shape, you can also connect it between these 2 terminals, something like this, or between the positive and the load. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. If you have this type, VDD ground and analog out, or for this one as well, the same way, VDD ground and analog out, the pins are connected in the same way. And here for the module, this pin is VCC. Using green wire, I've connected to pin 8, where we define this pin in the code as VCC for the module. And then the second pin is blue. Blue is not connected here, I just taped it. And then this purple is ground. Ground is connected here to ground of Arduino at this pin. And then the last pin, gray, is analog out, where we read the current. It is connected to analog 0. And for zero current detection, we need to prepare an LED with a resistor. The LED has 2 pins. The longer pin is positive or anode. The shorter pin is cathode. And we need to put a resistor between something like 300 to 1 kilo ohm. The value doesn't matter, because if you put larger value, the intensity of light will be reduced and there is no harm. So we will connect the anode, this longer pin, to the resistor and solder it, and the other pin of the resistor will be connected to 5 volts. In this case, we are going to connect it to pin 2 of Arduino, and the shorter pin is connected to ground. And here is the schematic for the above. So we have 5 volts goes through a resistor and then to diode, to the LED light emitting diode. This is anode, and the side that has line is cathode, and it will be connected to ground. And then LED that I've just shown you, I've prepared, it has been connected to ground and pin 2. Let me explain the code. The first thing that you need to do is download the library that I've written, download it as a zip file and save it in your computer somewhere, and then on Arduino click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, inside the PC, download and tutorial, and this, if this was the zip, select it and click open. The library will be installed. After that, close Arduino. Make sure at the bottom there is no other instance, so there is only one. Close them all and reopen it. After that, click on File, Example, and scroll down, and you will see Robojax WCS Current Sensor. Under this, you will have a lot of examples. Click on WCS Basic. So this is a basic current measurement, and this is the example that we are opening. All current sensors from Winson are listed here. This is the model, and this is the model number. And because we are using WCS1800, our model is number 12. So from this list, you have to find the model that you're using. Here, this is a wire that is for display, in case if you're using it with a display. And this is the Robojax WCS, that's a library that you just downloaded, and the model, you type it here, 12. And this analog 0 is a pin. We are defined it here as sensor pin. We are reading the voltage from the sensor at this pin, and we are defining a separate 5 volts at pin 8, because I'm going to leave the main 5 volts for display and other purpose. This needs very little current, 3.5 milliampere. And then the zero current LED pin, one pin is needed to be dedicated for LED, so pin 2 in this case. You can change these pins. And zero current wait time, this is a time that we wait before the LED is turned on, this LED. And I found through my experiment that this is a correction value. Either set it 0 or increase or decrease it through experiment to get proper value. But in my case, I put 165. At iteration is 100 measurement. We are doing 100 times calculation and getting the average. If you want more accurate value, increase this like 300, 500. And then the voltage reference, this is the supply voltage. I put this because sometimes you might supply your device with 12 volts, for example, 10 volts, and it can work, no problem. So we can put that voltage, but I would suggest keep it at 5 volts. And bit resolution, this is Arduino Uno, majority of Arduino are 10, but if you're using Arduino DUI or MKR. They are 12 bits. Debug once is a value that displays the debugging information on the screen, and if you set this to true, it will display once. I'm going to show you this. And here, this is from the class we create an object called sensor, and all these values that I've just explained will be passed here one by one with comma. So we are passing them to this class of library. Inside the setup, we are defining the serial monitor with 9600. If I click here, and on the right side in this section, you see that these are numbers. 9600 is the number that must match, otherwise you will not be able to see it. This is printing that text, and then sensor.start will start the sensor with all the settings. This line is printing the model that you're using. So anytime you need the model, sensor.getModel will give you the model number, and in this case we are using it as a print. Let me open the serial monitor after 5 seconds. It will display it here. Here it displays that's the model, WCS1800. Inside the loop we have to do this, and inside the loop we put this sensor.read current. It must be inside the loop, otherwise you will not read the current, but this is optional. Sensor.print current. When you put this, you will see the current on the serial monitor here. This is a value here, and if you don't want to do it, display it, just comment this and it will not be displayed. And if you want to get the current and do something, for example, sensor.getCurrent will return the value. So this is a value you can do, add, subtract, multiply. This is a number, and here we check it if it is greater or equal than 12.3, and then do something. If you want to do something, then open and closing parentheses here, and you can put your code here. I will have a separate video explaining this, how to control a relay to turn on and off a load when the current reaches a certain value. And then we have 500 milliamp loop, and the loop will continue taking the same action. And here we have print debug commented out, and if I uncomment this and then upload it, now if I open the serial monitor after 5 seconds of zero current, the debugging information will be displayed. This is the model, and here we are reading all these values. So this is very useful in case you want to make sure that the settings are correct. For example, sensor model is this one, and how many times you are reading, debugging, and then the reading from analog 0. So do not worry, after pin 13, analog 0 is pin 14, and VCC pin is 8, and then the sensitivity. For example, you enter the wrong value, you will see this one, and then zero current voltage 33 millivolts, which have been recorded, and then voltage reference 5 volts, correction value, bit resolution, and wait for zero current. So you get all these information. To not see them, just comment this out and it will not be displayed. Now if you set this, because this says debug once, if you set this to false, upload it, now if I open this, wait for 5 seconds, the value is displayed continuously. It reads it and displays it. In case if you want to connect the load and check and read, I don't know, whatever, for whatever reason, if you want to display it continuously, do that. So I'm commenting this out and setting this back to true. Now let me demonstrate it. When you turn it on initially, within 5 seconds that you can set in the code, the zero current indicator shows that the zero current have been recorded. So this is an LED that is telling us the status. And if I press the reset button here, you will see here, and it shows that a zero value set to 3.23 ampere. That's why now this LED is on. Turning the load with 5 ampere, Now the 5 ampere is entered. Let me turn it on. So 5 ampere is now passing through this cable, and we are reading 404.8, so almost 200 milliampere deviation. Let's go 7, again 300 milliampere deviation. 8, the deviation have been consistent almost. 9, so 10 ampere we are getting 9.6, so 400 milliampere. Let's go 15. Now 200 milliampere, so now it becomes very accurate. 16, 17, 18, very accurate now. 19, 100 milliampere deviation. 20, so now we are half ampere above the value at 20. Let's go 25. Now it's 25, and we are reading very close value, almost 100 milliampere deviation. Let's go 30. Now 30 ampere is passing through this cable, and we are reading almost 1.5 ampere deviation less. So now it's 1.5 ampere less, 28.5 almost. Let's go 35. So we are reading 31, so 4 ampere deviation. So at 35, this is not working properly. So it's not linear. Now let's go 30. Reduce it. So at 30 also was almost 1.5 ampere. So 25 is the best value that you are getting. It's very close, accurate value. So let's go 1 ampere, even smaller value. This is almost 120 milliampere deviation, but very better than other values. Let's go 0.5. So 500 milliampere, we are reading it at 390 or 400, so 100 milliampere deviation. Let's go 10 back, jump. So half ampere or 450 milliampere deviation. So conclusion is that we can get up to 25 ampere and not above that. So this is the result. Now this is now 25 ampere, and let me show you if I now the load is connected, and in case your Arduino boots up, this is what happens. I'm pressing the reset button, and pay attention now. I'm stopping it. You see it recorded 28.5 for the zero current. Remember there was 3 point something and now 25. That's 28.25. So if you forgot it, that's what we read now. Let's see if I turn this off. Now you read minus 25 ampere because nothing should before there was going the current. Now the current is stopped, so now minus 25 is being recorded. For that reason, make sure that when you boot Arduino, the load must be disconnected. So let's reset it again, and as you can see, it has recorded 3.27 ampere, and it is on now. We can trust this, and if I turn this on, 25 ampere is shown properly. In this tutorial, we are going to just use one of them, which the code will work for all. I'm just using one WCS1800 or with a LCD1602, the LCD2004 with 4 line, and we will be able to measure the current. Because when the load is not connected, we have a zero current value, meaning the sensor always reads some value. We have to subtract it from the actual reading. So we do that at the beginning of loading this. We can set the time in Arduino, which is currently set to 5 seconds. Within first 5 seconds, it will read the zero current, and here I put it as ZC, so it is 3.22 ampere. It shows continuously in here. And when you're using 2004, then you will be able to see one line and then the current and then zero current. Of course, you can hide this zero current if you don't want it from the code, so you can turn it on and off in both displays, either the small one or the large one. Make sure that when you turn this on, when you reset the Arduino, make sure that there is no load connected, so this can read a proper zero current. For example, right now it says 3.14. Reboot it. I just press the reset. You will see that it shows a current and then current sensor, and after that it reads the zero current and it shows the zero current 3.18 ampere. And the load. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. This is the negative of my power supply, and that's the positive. The negative I've connected directly. This is the load. I'm connecting it to my load, and this is the positive, passing it through this, and will be connected to my load. This is my load. Here I've prepared this wire. This is the 10 AWG wire that can handle over 70 ampere. So I'm going to connect it like that. Pay attention when you're wiring the bare module without the PCB. You have to connect between the Vout and the ground. We need to connect a capacitor, 0.01 microfarad, that is 10 nanofarad, to 0.1 microfarad, which is 100 nanofarad, to reduce the noise. But if you're getting PCB, the capacitor is already included. This is a capacitor. And on this module, this is a capacitor. It's already included. This side is VCC, green. Green is connected to pin 8, where we define this pin 8 as additional 5 volts. So this pin now works as 5 volts. And then ground, this purple is connected to ground here of Arduino. And the last one is analog out, the gray. Gray is connected to analog 0 here. And here for the LCD, either this module with 2004 or this 1602, they're all the same. For this, from this side, the first one is ground. Ground is connected to ground of Arduino in here, and the second pin is VCC, which is connected to 5 volts of Arduino. You have to connect it to this 5 volts, and then this pin from the last second is SDA. The orange is connected to analog 4. And last one is SCL. It is connected to analog 5. So these 2 pins are I2C pins, or you can connect it directly to these SDA and SCL in here. Now let me explain the code. First, you need to download the library. I will provide you the zip file. Once you click and download it, save it in your computer somewhere. After that, click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, in my case, if it was inside download and tutorial, and if this was a zip, select it and click open. After that, make sure to close Arduino. If you have multiple of these at the bottom, close them all and reopen it so you can see the list of library and all the options. Then click on File, Examples, and scroll down until you see it with R, Robojax WCS Current Sensor, and here you will see Robojax WCS LCD. And here is the code. You have to select your module, whatever model you have. If this is the model that you're using, you will select 0. So read this from this list and find out which number belongs to the model that you're using. And for this test, I'm using WCS1800 and the model is 12. So find out the model that you have. It must be there. And here we are creating including the Robojax WCS library. Here we are defining the model that we have, 12. And here we are defining the analog pin for the sensor where we read it. And this is the sensor VCC pin, pin 8. This setting from this line below is up to here. That's for the LCD. And this is the I2C address or I2C address for the module. This module's address, it has its own address. Either if you have larger one, for both of these you need to know the I2C address. As you can see, I've already printed them. In order to get that, go to File, Examples, again WCS Current Library, and then I2C scanner. Open this. We do not worry what is inside it, just upload it. If the wiring and power is up, upload it. And then open the serial monitor. It will show you the address 0x3f. This 3f is the address, 0x means hexadecimal. If you are not able to read it, on the right side, on the lower section, it says the baud rate and it says 9600. You must set it to 9600, otherwise you will not be able to read. So I'm closing this and closing this, and that is the address that we got from the I2C scanner. LCD character, how many characters it has. If you're using this one, it has 16 characters and 2 lines, and if you're using the larger one, it will be 20 characters and 4 lines. So we enter here 16 or 20 and enter here 2 or 4 depending on the module that you have. Title current, the word current, and then this title 0 current. These are the 2 titles that are displayed on the screen. Either on this small screen as well you will see the current, but if you're using the larger one you will see also 0 current. So you can change this accordingly to the other language that you prefer. This line has been commented out. If you're using another pin for VCC to supply 5 volts for the LCD and leave the 5 volts pin and leave the VCC empty for other purpose, uncomment this like that. So you will define a digital pin here. In this case, pin 9 will be defined for the LCD. I don't need it, so I'm going to use the VCC. And here 0 current wait time, how long it should wait to measure the 0 current, 5 seconds or 5000 milliseconds. Correction value, this is through experiment I found out that 164 will correct the reading, and if you wish you can change it, either reduce it or either put minus value or plus or 0. Measurement iteration, how many measurement you do, 100 or 300 or whatever. You can, the larger the value, the more accurate the reading, but it will be slow. You can find out what number works for you. And voltage reference, this is 5 volts. This module can work, for example, up to 12 volts, but if you are powering it from Arduino, you can put here 5000. I recommend to use 5 volts because Arduino will work with this. And then the bit resolution is the resolution of analog read. And if you're using Arduino DUI or MKR, it will be 12 bits. So change this 12 bits, and if you debug one, you're running the debugging to display information, which I'm going to show you next. You can set this true, so it will be shown only once. I'm going to demonstrate that. And here we are creating an object from the class, call it sensor, and we pass all the values that we define above in here with comma. All the values that we defined, it will be passed to the class for the library to be used. And if you're defining a digital pin for 5 volts, make sure to uncomment this. You see these are already commented. To uncomment it, just select, right click, and then it says comment, uncomment, and now this will be uncommented. But you cannot use both of these, so we have to comment this out like that. Now this will not be used, and the one that has this VCC pin will be used. I'm not using it, so I'm commenting this and uncommenting this one. And inside the setup, we define the serial monitor with 9600, which I've just shown you. You must set that the serial monitor when you click here the same value. This is just displaying the text on the serial monitor. Sensor.begin, initializing the sensor. So all the pins and settings will be set and it will be ready. This line is printing the sensor and printing the sensor model. If every time you need to get the model of the sensor, just type sensor.getModel with this function, so this will return the value. In this case, we are just printing it, making sure that the model that you've selected is the model that is that you have. And this is library version. It will print the library version, sensor.version, so this way you know which model you have. And if you want to see all the available models, just uncomment this and let me upload the code. And let me open the serial monitor, and after 5 seconds zero current reading, let me remove the auto scroll. Here it prints the model that you have selected. If you have selected 12, it will be like this, and other number will show proper value, so you can check with your model. And here this is the library version. It says version 1, and then this is the text from the these models. When you print the model, it also, when you print all the models, it also prints again the version, and each model will be displayed. So you know this is the model and this is the number that we need to use, and this is the sensitivity of the model. I uncomment this and upload the code and open it again after 5 seconds of zero current reading. Now it shows the version and the model only. We must have this line, otherwise you will not read the current. It says sensor read current, so this will read the current and display it on the screen, and we have 1 second delay. You can reduce or increase it as you wish. And this is sensor print debug. This will print the debugging information. All your settings and everything will be printed on the serial monitor. Let me uncomment this and then upload the code, and let me now open it. So, and here as you can see, it after printing up to here, it printed the model, and so it says reading from pin 14. Do not worry, analog 0 is pin 14 on Arduino Uno. After pin 13, analog 0 is pin 14, and VCC pin is pin 8 for the sensor. And this is the sensitivity and the zero current voltage that have been recorded, the voltage reference, the correction value, the bits, and the zero current time. And after that, it will show the current that has been measured at that last moment. So you can uncomment it and get rid of it like that. And if you want to display the current on the serial monitor, this is, you use sensor.print current. Now let me uncheck this and upload the code, uncomment. I've uncommented this line and upload the code. And this is how it just prints the current on the serial monitor as well. Now let me demonstrate it. When you turn it on, initially it shows the zero current. The zero current has been recorded as 2.75 ampere. So this should happen before you connect the load. Make sure the load is off and then turn this on and wait until you see this. Now I'm going to do the reset switch in here, and let's see. It boots up current sensor, and once it is recorded, then it shows the zero current. Now this is the current at the moment, because we see here that value. Let's go 10 ampere, and now this is 10 ampere and we are reading 9.6 here, almost 400 milliampere deviation. Let me go 11, so 500 milliampere or 12. This is the actual current, and now let's go 15. So that is now 14.75, 250 milliampere. It got accurate. Now let me increase it slowly, so we are now 16 ampere, almost 200 milliampere deviation, 190 something, 17, so it got more closer, 18, so 19 ampere, almost 150 milliampere deviation. It got very accurate now. 20, now at 20 ampere we are reading almost 500 milliampere deviation. Let's jump to 25. Now this is 25 ampere is passing through this wire, and we are reading 24.9, very accurate, 100 milliampere deviation. So let's go 30. Now the current is 30 and we are reading 28.4, so now this is now almost 1.5 ampere deviation, which is not good. Let's go to 35. We are reading 31, so 4 ampere deviation, which is very bad. So what we come to conclusion is that if I go for 25, we are reading the most accurate value at 25. So 9.6, almost 400 milliampere deviation. Let's go 2 ampere, very low value. Now this is very accurate with comparing to the previous value. It's almost less than 100 milliampere. Let's go 1 amp, so 920, and this is 1002. Let's go 0.5. Now this is 500 and we are reading 440. So still, because this is made for higher value, still it's acceptable. So keep that in mind, that we can measure up to 25 ampere. Connecting the large display, so I'm changing the I2C value, changing this to 20 and this to 4, uploading the code. As you can see, it shows this text first, and it shows the zero current to be 3.68, and here is the mistake that I made, and it was on, so I have to turn this off and then press the reset switch so we can read it properly. Now that there is no load is off, and now we are reading proper value and the zero current is displayed. Because this is larger screen, we can put the proper text here. And if I go 25, it shows the same as before properly. And here is a problem: in case even at 25, if you press reset button or the load is connected, when you turn this on, here is what you read. It will record 25 as zero current. It thinks that there is no load supposed to be, so 28 is now. Remember, it was 25, 3 point something, so now plus 25, it's 28. Now this is reading it. Now if I turn this off, you will see minus 24.9, so that 25 was there. So in order to avoid this, make sure that the load is off like that, and then press the reset button, this reset button, or turn this on the power, or turn the power on. Now it will record the zero current, then you can proceed. So if I turn it on now, 25, and we are reading very accurate value, or something like this. To learn and just grab the code and run it. The link for the code is below the video in the description. Overcurrent protection is used in many applications, in battery charging or for current monitoring in different applications. And I'm using Robojax WCS Library for Winson WCS Current Sensors. The library that I've written will work to read the current from any WCS current sensor. This is just an example, and you can simply select the model that you have and the code will work for it. I have separate video and introduction for that. Also, I have separate video how to display the current when you measure it, display it on an LCD. This is only for overcurrent protection. I'm not going to explain all the specification of the sensors and how they have been implemented, because I've already spoken about those in a separate video. This video is just to implement and make this work. In order for the project to be successful for you, please watch that introduction video for WCS current sensor and make sure that you are able to display the current on a serial monitor. After that, also watch another video that I've implemented to display the current on a LCD. And after that, then come to this video. For the LCD, you don't need separate library. I have incorporated the LCD library with the Robojax WCS current sensor. So I've made it very simple. This module needs 5 volts and the LCD also needs 5 volts. The relay needs 5 volts. Because this needs about 3 milliampere and this needs about, I've used the digital pins as a VCC for this, so this gets the power from pin 8, and also for this one I've implemented pin 9 to supply 5 volts for this, because I wanted to leave the 5 volts empty for relay, because relay needs about 80 milliampere and Arduino digital pins cannot supply it. But of course, if you need to use the digital pins, these digital pins for something else, you can do so and supply direct 5 volts for these modules. That's also okay. So how it works is that we are connecting the power and it passes through the current sensor. Doesn't matter this type or many other types of the current sensors that we have with the WCS. The current reaches that threshold value that you set in the code. You will also set the time, how long it should wait. So once it detects the current, it will disconnect, but you cannot simply just disconnect it and then continue like that, because the current will be immediately 0 and this will reconnect it back. So to prevent that, I've implemented 2 methods. First, we will keep it waiting, let's say for 5 seconds, 10 seconds, whatever time you set, and it will wait and then reconnect. This will be useful for some people, but in some applications when the current reaches certain value, you don't want the load to be ever connected again. So you have to disconnect it and keep waiting indefinitely until somebody comes and checks it. You can do that also in code very easily, to wait or not wait forever. Another important factor that you need to know about the relay is that the current rating of the relay that can control is, for this relay, is 10 ampere, and also you can implement this type of relay. Doesn't matter which module you use, but these are 10 ampere. If you want to control higher current, there is this type of relay that I found on Amazon and eBay. This is 80 ampere. What it means is that the load that you're connecting from this cable, it will come through this relay. This is 80 ampere and it can handle 80 ampere. If you're using above 80 ampere, let's say 100 ampere type sensor or 200, you can implement 2 or 3 of these in parallel to make 2 times 80, 2 times 80, 160, or 3 times 8, 240, and so forth. You can connect these in parallel to increase the current. I will try to make a separate video connecting all these relays in parallel to increase the current. If you connect 2 relays in parallel, it will be 20 ampere. You can increase the double it, and if you put 3 of this, it will be triple, and so forth. And let me talk about these 2 relays. This is a high trigger relay, meaning input signal at this pin, this S signal, When it receives anything above 2.5 volts, it will turn on. When it receives below that, it will turn off. So it's high trigger with high voltage. But this one at this pin, when it receives anything above 2.5 volts, it will turn off. And when it receives below that, it will turn on. So this is called low trigger. This has an LED here. When it has power, it will be turned on. When it receives the signal, the green will turn on this, and this relay will energize and disconnect or connect. But this one has only this LED, and this will turn on only when it receives the signal. For these pins, we have this is normally open, and this is also normally open. Middle is common. The last pin is normally closed. So in this one, we are using it between common and normally closed because we want the load to be connected all the time except when the load increases. And in this one, we will connect it between these two because the signal will be always at the input, and this will always have some low signal and it will be on. So we have to connect it at normally open. So this will be always on and will be disconnected when it receives the signal. Keep in mind that this one needs continuously 80 milliampere to operate, and it consumes energy, and it will stop using energy when the signal, when the current reaches above threshold value. When it disconnects the current, then the relay will be turned off. So this uses some energy while in normal operation. This is the opposite. In normal operation, it doesn't use energy. The current passes through, but when it receives the signal and when the current is above the threshold value, this will just energize and consume energy to disconnect the load. So these two are opposite of each other. This is not a desired method in case if energy is your concern. If not, that's okay. So here you will connect your sensor, load, and relay, either something like that. You can connect it the positive and the positive line, or you can combine them between positive and negative. I will provide you all these diagrams so you can use them and do not get lost. Or you can use it if you have a PCB version, you can use it like that, or maybe put the relay in the negative line and the sensor at the positive line, both of them at the positive line, or if you have this WCS2750, you can use it like that, like this, or in this combination. And if you have this type of sensor, you can put it at the positive, at the negative relay, move the relay. So these are all the combinations, so you cannot make mistake in wiring. And now let's see how we can connect it. This is your load, and you have a battery and you have a sensor. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have this shape of sensor that will pass hole through, or maybe a module, something like this, that a 2-wire will be connected here, which I'm going to show you, or this module, or this type with the 2 terminal on the side, or if you have something like this, or something like this. You can put your sensor between the load and the negative terminal where the current will pass through, or you can put it between the positive and the load, or you can put this one between positive and the load, and it will just pass through that. Or you can put it at the negative, the same module here. Or if you have this type of module, you can solder the 2 wires between the negative and the load, or between the positive and the load. And if you have this PCB version, you can connect the 2 wires in this 2 terminal, or between the negative and the load. And if you have this shape, you can also connect it between these 2 terminals, something like this, or between the positive and the load. So you will connect it in series, and we are reading the current through these 3 pins. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. And if you have this type, VDD, ground, and analog out, Or for this one as well, the same way, VDD ground and analog out, the pins are connected in the same way. This is my power supply, this is a negative, that's a positive, and this is my load. The negative will be connected like that. The positive is coming and passing through my sensor. Doesn't matter which type of sensor you have. Either if you have this type of sensor or these type of modules, doesn't matter. For all of these, you will just connect it and pass through the module, and it comes here, and it comes from here. It comes back to the relay, to the middle pin of the relay, this type of relay. If you're using this low trigger relay, then it will be the middle and the other pin. Pay attention, middle and the other pin. But if you're using this one, it will be middle and the left side, and this will go to my positive of load. So that is done. And for zero current detection, we need to prepare an LED with a resistor. The LED has two pins. The longer pin is positive or anode, the shorter pin is cathode, and we need to put a resistor between something like 300 to 1 kilo ohm. The value doesn't matter, because if you put larger value, the intensity of light will be reduced and there is no harm. So we will connect the anode, this longer pin, to the resistor and solder it, and the other pin of the resistor will be connected to 5 volts. In this case, we are going to connect it to pin 2 of Arduino, and the shorter pin is connected to ground. And here is the schematic for the above. So we have 5 volts goes through a resistor and then to diode, to the LED light emitting diode. This is anode, and the side that has line is cathode, and it will be connected to ground. And here for the current sensor, this pin is VCC. It has been connected using green wire to pin 8 here, where we define the pin 8 as VCC for the module. And the second pin is not connected, the blue is not used. The third one is ground. Ground is connected using this purple wire to the ground of Arduino. And the last pin is analog out, the gray, where we read the current, is connected to analog 0. And then LED that I've just shown you, I've prepared, it has been connected to ground and pin 2. And here for the relay, this pin is S, or signal, using orange wire. It has been connected to pin 3 and here. And then we have this, the middle pin is the 5 volts VCC or plus sign. It has been connected to 5 volts of Arduino. And the last pin is negative or ground. It has been connected using this brown wire to ground of Arduino. And if you're using this type of relay, this side is VCC. Using red wire, it has been connected to 5 volts. The middle pin is ground. Ground is connected to the ground. And the last pin is labeled as N, or input, where the signal is connected. It has been connected to pin 3, or whatever pin you define in the code. And then for the LCD, this side is ground. Ground is connected using brown wire to this ground of Arduino. The second pin is VCC. This is connected using this red wire to the pin 9, where we define the pin 9 as VCC for the LCD. And then we have two pins here, SDA and SCL. I have SDA and SCL. SDA is connected using orange wire to this SDA, and SCL is connected from this last one using yellow wire to this SCL. If you don't want to use it, you can also use this analog 4 and analog 5. Analog 4 is SDA and analog 5 is SCL. First, you need to download the Robojax WCS library. Download it as a zip file, save it in your computer. After that, click on Sketch, include library, add .zip library, and then point it to where you have saved it. If this was inside the download, for example, and then tutorial, and if this was your zip, select it and click open. The library will be installed. After that, you have to make sure this of Arduino that you have. So close them all and then reopen. Then go to File, Example, scroll down until you see R, Robojax, and here Robojax WCS Current Sensor, and go to Robojax WCS LCD Relay, and this will be the code. I'm going to explain the other code. This code is with the LCD, and the one that has no LCD, we just remove the LCD section and it will work. First, you need to select the model that you're using. If you're using, for example, WCS2801, your model is 2. And if you're using the 1500 WCS1500, your model is 9. So keep the model number. I'm using WCS1800 and my model is now 12. This is for LCD. This is a library, Robojax WCS library, and the model that you have will type it here, 12. And the sensor pin that you're reading the current is analog 0. You can change it to any other analog pin. Sensor VCC pin, we're defining a pin to supply power for VCC, that is pin 8. You can change it. And here for the LCD, we need to find out the address for the module. If you're using this 1602, this is the module that has I2C address, and if you're using this larger version 2004, it has this module and it has I2C address, so we have to find out the address. Now for that we have to upload separate code, and I'm connecting it directly to the power supply, not to those digital pins. So it has been connected directly to VCC and 5 volt and SDA and SCL, which I've explained it in the wiring section. So in here, now let's go to File, Example, and go to WCS, Robojax WCS Current Sensor, and open I2C scanner, I2C scanners. Do not worry what is inside it, just upload it. If your wiring for LCD is correct, it will be uploaded. And now I'm opening the serial monitor, and you will read the I2C address for the module. It says 0x3f, and it will read it every few seconds. And if you cannot read the number here on the right side on the lower section, it says 9600. Make sure it is 9600. So we get 0x mean hexadecimal and 3f is the actual hex value number. So let's close this and close this. So I've entered here 0x3f. This LCD character is 16 characters. Refers to this 16 characters that we have here, and then 2 means 2 lines. And if you're using this one, it will be 20 characters and 4 lines. So we will enter either 20 here or 16, 2 here or 4, that is number of rows. And then the title 0 current. And then this title and these titles, these are the 2 titles that are displayed here, current sensor and also current, and the model that you select will be automatically displayed. And we have defined a pin for VCC pin for the LCD. I've defined pin 9, and here shows 0 current true. If you set this to true, the 0 current will be displayed. You see 0 current is displayed. But if you set this to false and upload the code, now the code is being uploaded. And it will not display it. It will measure it, but it will not display it. So it's up to you if you want to eliminate it. I'm just making it true. And here's the current wait time. This is 5 seconds. We need some time to measure the current and also make sure that your load is off and not connected. So this is the time that you wait. You can change it, make it shorter or longer. The correction value, I've explained it in the introduction. Measurement iteration 300 measurement, I've explained it. This is the voltage, and these are all the things that I've explained in the main code. So these are all for LCD, and if you're not using LCD, you will not be concerned, you will not see this. I'm going to show you the code quickly. And for the relay pin, we have defined a pin for relay, and this is the current that you don't want to go above it. So the current is set for 12.5 ampere. When the current reaches 12.5, the load will be disconnected. Any current below this will be connected. And here relay type, if your relay is high trigger, put high trigger, and if it is low, put a low trigger. This relay is low trigger and this is high trigger. And these are variables, relay on, relay off, will be used inside the code. And this is the whole time, how long you want to wait when the current reaches to this value, for how long you want to keep the system disconnected. And if you want to make it longer or shorter, it's up to you. But if you want to disconnect it forever, stop. If you want to stop it, currently it says false, which means it will not stop. But if you want it to stop indefinitely, just type here true. This is all lowercase. These are defined constants. If you type it in lowercase or mixed up, it will not work. From this library, Robojax WCS, we create an object called sensor, and we pass all the value, the address, the character, the sensor pin, all those values that we define at the top. They will be passed and sent to the library to be used and prepare the code for us. And here we are using this portion because we have a VCC pin for LCD. If you are not using it, then do not use this. It will be a waste of pin. Then use this. How to use it is just right click and remove all this. In Arduino there is a feature in Arduino IDE, right click and then comment, and comment, it will be automatically uncomment, and then make sure to comment this. Right click and then comment. You cannot have uncommented both of these, you will get error. So in my case, because I'm using the VCC pin, I will comment this out and then uncomment this section. And here inside the setup, we define the serial monitor to display the text for us with 9600 baud. So this is a text that is displayed on the screen, and sensor.begin is where we must have it. It initializes the sensor. This will print the model for the sensor. Next line, it prints the version for the library. So if you want to know the version, just at the beginning, if you open it, wait for 5 seconds because it goes with the zero current, and here it shows the sensor and the version. I will update the library from time to time so you know which version you're using. And if you want to print all the models that is supported by the system, uncomment this and it will print all of them for you. We define using pin mode, a relay pin as an output. This will be setting the pin as an output, whatever pin you have. And here this portion checks if the relay trigger type is high, then we set the relay pin low, so the relay is initially in normal state, off, and then these variable on and off, we set them properly because it's high trigger, so on is high and off is low, and if it is not high trigger, it says else. Here we set the pin, the relay initially high to be turned off, and then for on we set it low, and then for off we set it high. Pay attention, these are the opposite of each other. So this portion will take care of the trigger type of relay. Inside the loop, sensor read current. This must be inside the loop, otherwise the code will not read the current. And then we have 1 second. You can change it if you want to make it faster. And then we have to have relay control. This will control the relay based on the available current. We must have it. These are optional, these two. Print debug. If you remove this, I've explained it in the introduction and in the LCD section. So this will print all the debugging information, and this will print on the serial monitor. If you are not using LCD, then for sure you will uncomment this, and this will continuously, let me upload it, it will continuously print the current on the serial monitor because you will not have a LCD. Right now there is no current. This is for zero current, 5 seconds. And after that it will read the current. So right now this is the current that it is reading every 1 second that I've set it. Like that. And inside the relay control function, when we run this from the loop, it comes again, it checks if the current is, if you want to do something with the current, this is the current. This will return or get the current for the from the sensor, and you can do something with it. For example, if the current is the current is smaller than 3.5, you want to do something, this is opening here and closing here, do whatever you want in this line. Current is greater or equal to the current that we set at the top of the code, then we set the relay pin on. This on and off changes according to the relay type, and then we print this text on the screen. Current reached with this value ampere. So then this is the value, and then we print A, and then we say relay on. And if relay stop is true, then we say here waiting forever, and then while 1. This while 1 mean wait forever. Else, if stop is not set, we just say waiting for this many seconds. So we get the hold for, which we set it for 5 seconds or 6 seconds, 6,000, we divide it by 1,000, so we get second, and then we print the text at the end, this many seconds we will be waiting, and then we apply the same amount of time with a delay, so it will keep the system waiting, and after that it will pass. Now, if the current was above that, the set value, all these action will take place, else again it will go back to turn the relay off using digital write, the relay pin, whatever pin you have connected it, and it will turn it off. Now let's go through the code without the LCD. Go to File, Example, and scroll down to Robojax WCS Current Sensor, and then select Robojax WCS Relay. So click that and open it. This will be the code. The difference between the previous code and this one is that we do not use the LCD settings. Nothing is here. We have only relay, and the setting that was for LCD here, it's gone. And we are using one constructor here, and very simple. The rest of the code is exactly the same. Inside the loop we have sensor.print current, which will read the current continuously for us. Let me show you. When I open it, it takes 5 seconds for the zero current reading, and after that it just reads the current like this. Now let me demonstrate it with the LCD, and then I'm going to demonstrate it without the LCD. Now at the moment the current is 0, and you can see the current also on my electronic load shows that it is 0. This relay also will have the light when the current reaches our threshold value. When the current reaches 7.5 ampere, I've set it to 7.5, it will turn on. It will turn on, and this light will turn on. Remember, this relay is 10 ampere, so we will not go above 10 ampere for the test. As I mentioned, if you want higher current, this is 80 ampere or higher, you can find different relay to control different amount of current for current protection. When you boot this up, make sure the load is turned off, and when I press the reset button on the Arduino, you will see here the zero current is now read as 3 ampere. So let's turn it on and off, and so you can see it takes 5 seconds for the zero current to be read, and we will see it here. And now this is the current, and here I'm gonna go with 5 ampere. Now this current is turned on to be 5 ampere, and we are reading it in here. The delay that I set is 1 second, so it reads it after 1 second. And that is this relay. Let's make it 500 milliseconds. And then turn off the load. Make sure the load is off, and this is now when the code is loaded, it will again read the zero current. Make sure the load is not connected. My load is off, so this is now the current, and then let's turn on 5 ampere. So the current is now 7.4, and if I increase it to 8, now the load is disconnected, and as you can see the current is now 0. Now this is set to hold it for 5 seconds or 6 seconds, and now it will turn on, it allows the code, and it will continuously do the same thing. So perhaps for some applications you do not like this. You might need to set it to be off forever. So what we do is now here on the code here it says stop, and let's set that to true and upload the code. Let me turn off the load. Now this is booting up. Now there is no current. And let's turn on it with 5 ampere again. And I'm going 6 and 7. At 7.5 it will turn on, so now 8. So you will see now this is turned on, it will never turn off. So the load is now disconnected and it's just holding the last current that it was reading, and until you come and reboot Arduino or disconnect the power, this will just stay there. So this is another option that you can check, and maybe you find a fault or something and take action. Now let me demonstrate it. When you boot the Arduino initially, it will read the 0 current and it will turn on. I'm just resetting it by pressing this reset button in here and wait for 5 seconds so you can read the 0 current. The load is off, and here now we are reading about 70 milliampere even though there is no current. I've set this delay in the loop 300 millisecond. I'm setting the current protection to be 7.5, so it will allow up to this value. System is ready. Around now it's 4.8 ampere here you're reading. Five ampere is read at about 140 milliampere less, and I'm changing it from here, making it 6. So you will see here 6 ampere, and here the current is shown here. Let's go 7, and the current is shown. When it reaches the value 7.5 ampere, as you can see, it was disconnected, and then it is connected back. Now to show you here, it says delay, and here to show you it says current reached, relay turned on, waiting for 6 seconds. So it waits for 6 seconds and again reads it, and immediately it detects it is 7.5, and so it continuously does that. And perhaps this is not a good way to implement the overcurrent protection, and we need to set this so it can stop forever. If you want in that case to stop it forever, on the code here where it says stop, change this to true. So now stop is true. Let me upload the code. Make sure it is off because there should not be any current. After a few seconds it reads the 0 current. Now 0 current is read, 3 point something, and this is the current that we are reading. So again let me go 5 ampere, and this is 5 ampere. Let's turn it on. So we are reading the current here, and let me increase it slowly. So 6, now 655. Now it's 7, we are reading 7.49. So as soon as the current reaches, now this is waiting forever. And here at the lower section of the screen it says current reached 7.5. It was 7.57, so it reached, and relay turned on, waiting forever. This relay will not allow any current, and as you can see the light is on, and it will be waiting until somebody comes and attends this and checks why the current is above the value. So to restart this, we must press the reset button here on Arduino, this reset, and make sure the current is off, and then press reset so it can read the 0 current, and it will be ready again.